Hi everyone. Today we're going to look at some more polar information. Now, if you look at the news item that I sent out today, it talks about how I've extended the deadline for this particular assignment and next week's assignment to the 29th and then to the 5th for each. That's one reason why I have all that flex time at the end. If you look, originally we had 18 days of flex time. That's because I find that these particular topics we're going over in Chapter 8 are difficult for students. So let's talk about how we can help you out a little bit more. So let's take a look at some things. I'm going to send this out. I sent it out. Whoops, don't want that. I'm going to send this out to you. This is some more examples of things that we've been doing. Okay, so this would be questions from section 8.1, 8.2, section 8.1a, 8.1b, and 8.1c. So a lot of this is about converting. So we're converting from rectangular to polar and from polar to rectangular. Now the conversions from rectangular to polar are a little bit more detailed. So let's do those first. So we have three examples. Okay, so the first thing we always do is we find r. Now remember, x squared plus y squared equals r squared. Why? Well, because x is equal to r cosine theta, so that'd be r squared cosine squared, and y is equal to r sine squared, or r y squared is equal to r squared sine squared theta. And so if we factor the r squared out, we'd have an x squared plus y squared, which gives us an r squared. We plot this out, that'd be step 2, and then we use the tangent inverse and adjust the proper quadrant using the reference angle. So we're going to do a little bit from that first trig packet here. So you might want to pull your first trig packet out, and I ask you to fill in a unit circle with the special angles. That comes into play here quite a bit. If you get a negative tangent, inverse tangent in this case, take the absolute value and use it as a reference angle. So let's look at A. So A, we're asked to convert this minus square root of 2 to square root of 2 to polar. So the first thing we do is we find r. So that's going to be minus the square root of 2 squared plus square root of 2 squared. And that gives us 2 plus 2 or 4. So that means r is actually the square root of that. So that should be 2 actually. And so that means that we graph this out. We need to correct that to 2. Sorry about that. We need to graph this out. So that's our angle theta. It's in the second quadrant. Okay. And then minus square root of 2 over square root of 2 is 1, and negative 1, and inverse tangent of negative 1 is minus pi over 4. So we adjust to give us a reference angle of pi over 4. And reference angles in quadrant 2 are going to be pi minus the angle. So pi minus pi over 4 is 3 pi over 4. So we should get 2, 3 pi over 4. Let's look at the second one, the square root of 3, 1. So again, first step, find r squared. So the square root of 3 squared is 3, and 1 squared is 1. So that gives us 4. That's r squared. Square rooting, we get 2. Okay? And so finding a reference angle, we take the tangent inverse of 1 over the square root of 3. So when you think about that for a minute, well, let's see. 1 over the square root of 3. Where is tangent equal to 1 over the square root of 3? It's equal to 1 over the square root of 3 at pi over 6. Okay. And so, and also in the third quadrant at 7 pi over 6. That side, this is the first quadrant. So we use the pi over 6. And we get 2 pi over 6 for our point. And the last point is minus 7 square root of 3 over 2, minus 7 over 2. And again, we go through the process of finding r squared. R ends up being the square root of 196 over 4, which is 14 over 4, which gives us 7. And again, we go through the process of finding tangent inverse of minus 7 over 2, minus 7 square root of 3 over 2. We reduce that. We get 1 over the square root of 3 again. And that, again, has a reference angle of pi over 6. This time, it's in the third quadrant. So in the third quadrant, reference angles are always pi plus the angle, the reference angle. So this gives us 7 pi over 6. So we end up with a point of 7 pi over 6. Okay, so again, step 1, find r squared. Step 2, figure out what quadrant it's in. Step 3, use tangent inverse to figure out the reference angle, or use your unit circle to figure out what angle gives you the value that you're taking a tangent inverse of. You can do that either way. Okay. And then once you have that, you have the point. To convert to rectangular or Cartesian coordinates, remember x is equal to r cosine theta and y is equal to r sine theta. So if we have the point 3, 7 pi over 6, we just plug those values in. Our first point is r, and the 7 pi over 6 is the angle. So 3 cosine 7 pi over 6 gives us 3 minus the square root of 3 over 2. And so we multiply that out, we get minus 3 square root of 3 divided by 2. And then for y is equal to 3 sine 7 pi over 6. That gives us 3 times minus 1/2. And 3 times minus 1/2 gives us minus 3 over 2. Let's try another one, b. Okay, so for b, we start out with the square root of 2, 4 pi over 3 in polar form. So again, we use our conversions. X is equal to the square root of 2 times cosine 4 pi over 3. Cosine 4 pi over 3 is a half. So that gives us a square root of 2 times a half, or positive, and I just exaggerated the positive there, square root of 2 over 2. Okay. Again, if you're unsure about how to find these values, go back to reference angles, go back to packet 1, go back to that unit circle, okay? Because they're coming into play here. And then we have it, and they'll come into play later too, in the trig packet that you're doing when you start solving equations. So have that right beside you, that unit circle right beside you, so you can figure out these values more quickly. Okay. And then for y, we have the square root of 2 sine 4 pi over 3. And so that gives us a square root of 2 times minus square root of 3 over 2. And so when I multiply the square root of 2 and the square root of 3 together, I get square root of 6. So I end up with minus 6, or minus rather, square root of 6 over 2. Then let's take a look at conversions of equations. We can convert a polar equation into rectangular form or Cartesian coordinate form. Let's look at this first one. R is equal to 3 sine theta plus 2 cosine theta. What we want to do is we want to get rid of the sine thetas, the cosine thetas, and the r's and change them to x and y's. So unfortunately, x is equal to r cosine theta, and this is just a cosine theta. And y is equal to r sine theta, and this is just a sine theta. And I'm not sure what r is equal to. I know r squared is equal to x squared plus y squared, but I don't know what r is. So I'm going to multiply everything by r. Okay? And so we get r squared equals 3r sine theta plus 2r cosine theta. So this r sine theta now is an x, or I'm sorry, a y, and this r cosine theta is an x. And then the r squared, well, that's x squared plus y squared. So now I can make the substitutions. This part is x squared plus y squared, so that's where the x squared plus y squared comes in. This part is y, so that's where the 3y comes from. And this part is x, so that's where the 2x comes from. And so we get the equation x squared plus y squared equals 3y plus 2x. Another example, this one looks a little messier, but we think about how we solve equations in rectangular form. We get rid of the denominator by multiplying both sides by the denominator. We do the same thing here. We're going to get rid of the 8 cosine theta plus 4 sine theta in the denominator by multiplying it by both sides. When we do that, it cancels it out here, giving us just the 7. Over here, we have r times the quantity 8 cosine theta plus 4 sine theta. Now, with that r there, I can multiply it through. I can distribute it through. And that's going to give me an r cosine and an r sine. which I want because that'll give me an X and a Y. So this part becomes X, this part becomes Y, and so we get 8X plus 4Y equals 7. Let's take a Cartesian equation or a rectangular equation and convert it to polar. So we start out with Y equals minus 2X plus 3. So we're going to replace the Y with R sine theta and the X with R cosine theta, and then isolate the R. So our goal here is really to get R by itself when we have this scenario. Sometimes it's not possible, but in this case it is, because I add the 2R cosine theta to both sides, giving us R sine theta plus 2R cosine theta equals 3. Now I'm going to factor that R out, and then I'll divide by sine theta plus 2 cosine theta, giving us R equals 3 over sine theta plus 2 cosine theta. In 4, they have a little trick they throw at you, which I don't think is particularly fair. This is one reason why I ask you to actually show me your work, because if you couldn't match this answer up, well, if you show me your work and you got what I have at toward the end here, that would have been okay. But they're trying to make you work a little extra. Sometimes math books and math programs do that, especially if you're going to take calculus. They'll do that a lot. So we start out with x squared minus y squared. So that's not r squared. And that equals 3x plus 2y. Now what I can do is I can rewrite x squared as r squared cosine theta, and y squared as r squared sine squared theta. So that gives us r squared cosine theta minus r squared sine squared theta equals 3r cosine theta from 3x plus 2r sine theta from the 2y. I'll factor the r squared out here. I'll factor the r out here. Remember, my goal is to isolate the r. I'll divide by r on both sides. That gives us r. And I'll divide by cosine squared theta minus sine squared theta on both sides. So that gives us this denominator. Now, chances are when you see something like this, they'll replace that cosine squared theta minus sine squared theta with cosine 2 theta. That's an identity. If you left it here and you show me the work up to this point, I'd be fine with that. So again, that's why I asked you to hand that in, because if it is that you didn't see that identity, which is possible, you still would get the credit for it. So hopefully this helps. We'll be looking at some graphing with the calculator. Again, notice I extended the dates somewhat on the due dates. Have a good day.